So in 8.1, we have what's called systems of linear equations. So remember, a linear equation is a two-variable equation. You have your input and your output, and they're both degree 1. So remember, the solution to a linear equation by itself would just be a point. But if you're talking about the solution to a system of equations, notice that you actually have to find the x value and a y value. In other words, you have to find an ordered pair that meets the conditions of both equations. So if you have a two-variable equation, you're going to have to solve for x and y. So we're actually getting into a two-dimensional graph or a line. Now, notice if you're looking for an x, y, and a z, a three-dimensional equation, you're looking in, x-axis, y-axis, and z-axis. That's third dimension. Then, like I said, it gets into the more complicated concepts of fourth dimension, fifth dimension, sixth dimensions, and so forth and so on. So if I have a fifth dimension equation, that means I have to have 5 variables. But if I have 5 variables, I have to have 5 equations. So luckily, we're not getting into that kind of stuff here. So we're dealing with linear equations. So we just have a two-variable equation. And these equations do represent lines. So some vocabulary we have to get into is what we call consistent and independent, consistent and dependent, and inconsistent. Consistent and independent means there is one solution. And it's going to be represented by an ordered pair, an x-coordinate and a y-coordinate. Consistent and dependent means there's infinitely many solutions. And what's going to represent this is going to be the equation of the line. That's not how you spell equation. I said line there and I threw an L in there. So the equation of the line, that's going to be the solution. Inconsistent means there's no solution. So there's no ordered pairs in common. So if there's one solution, that means the two lines intersected. And the point of intersection is where the solution is. Consistent and dependent means they're the same line. So that means the lines are what we call coincident. They lie on top of each other. And then inconsistent means the two lines are parallel. Which means they do not intersect. So that's why there's no solution. So if we want to solve this system of equations, we have this 3x minus y is equal to 7, and this 2x plus 4y is equal to 28. The strategy I would be using is what I call the addition method. So what I want to do is add these two equations together. But when I add them together, one of the variables actually has to zero out. So right now, if I add them together, both variables stay in the equation. What I'm looking for is the same coefficient, but they have to be different in sign. One's got to be positive, one's got to be negative. So what I'm picking up on right now is, this negative y could be easily made a negative 4y by just multiplying this top equation by 4. So what I'm going to do is I'm going to just multiply this top equation by 4. In doing so, my new equation is going to now be 12x minus 4y is equal to 28. So I'll multiply everything, both sides of the equations by 4. And what I'm going to do is bring down the second equation underneath of that. So the 2x plus 4y is equal to this 28. So I have this new system of equations. But in this system, notice that the y's are the same coefficient but different in sign, which means they're going to zero out. So when I add these together, the addition method, those pieces will zero out. So what I'm left with then is 14x equals, and 28 plus 28 would be 56. So if I want to solve for x, if I divide both sides by 14, 56 divided by 14, that's going to give me 4. So yeah, 14 times 4 would be 56. So that's going to be my x value. But remember, we have to now find the y value. So using any equation that we had up here that involved x and y, we can now do that. So I'm going to just use this 3x minus y equals 7 as the equation. So if I have this 3x minus y is equal to 7, what I can do is substitute the 4 in for x. So what I have now is this 3 times then. I can put this 4 in for x. And I have now minus y is equal to 7. And then I can solve for y. So this is going to be 12 minus y is equal to 7. If I subtract 12 on both sides, that's going to be a negative y. Oops. So it's going to be a negative y, or the opposite of y. And what is 7 minus 12? Would that be probably a negative 5? So negative 5. So if I take the opposite of each side out, you have y equals 5, or if you divide both sides by negative 1, you would have y equals 5. So my solution is going to be 4, 5. That's going to be my solution. So there's going to be what we would call, this would be consistent and independent, and then the solution would be an ordered pair. So see if we can put this on the graph. So let's see if we can actually show this in our work here. So notice how the solution is going to be like x equals this, y equals that. Now this actually is a different equation. So let's see what we got here. So that's what's to graph the lines on the system. So let's see here. That's a different equation. All right, let's go back to this. So if I want to graph these two lines, we're going to be using the line tool. So to graph the lines, basically what you need are 2 points. So if I look at the first equation, I have 3x minus y equals 7. We already know one of the points is 4, 5. So all we got to do is graph the 4, 5. So 4, 5 would be located here. What I need is a second solution. The second solution would be what we could call the y-intercept. So if I can find the y-intercept, all I have to do is set x equals 0 and solve for y. So if I set x equal to 0, you're going to have negative y equals 7. So y would equal negative 7. So 0, negative 7 would be another point I would be graphing. So using your graphing tool, once you plot those 2 points, the line should go, let's see if I can get a line to go happen here. This thing out of the way. So if I draw a line through those 2 points, that's not real good. That's better. So that would be the first line. The second line, what I could do again is graph the point 4, 7, or 4, 5, I should say. So all I got to do is plot one more point. Again, if I want to find the y-intercept, I'd be setting x equal to 0. So if I set x equal to 0, this term falls out, and I have 4y equals 28. So y would equal 7. So the other y-intercept would be 7. So that would be up here. So the second line should kind of go across there. So it kind of looks something like that. So that's what you kind of looking for, is a graph that kind of takes on that look there. So that would be our thing. So I believe all you got to do is plot 2 points. Well, the point intersection is going to be one of the points. So if we can find the y-intercepts, that may be some easier points to graph as well.